So trigonometric equations are treated just like algebraic equations in the fact that you can add and subtract cosines, sines, tangents, secants, cosecants, and cotangents, just like you do x terms. So to introduce this, what I'll do is pretend that this is an x equation. This equation reads cosine theta equals 3 cosine theta plus 1. Now I'm not going to solve it this way, but I'm just going to show you how we're going to treat it. Say we have x equals 3x plus 1, and how would you solve for x? You'd subtract 3x from both sides, giving you negative 2x equals 1, and then divide by negative 2. X equals negative 1/2. Well, we're going to treat cosines and sines and tangents and secants and cosecants and cotangents the same way. So we're going to add and subtract 3 cosine just like we did 3x. So subtract 3x from both sides, or 3 cosine rather. And now we end up with negative 2 cosine theta equals 1. And divide by negative 2, and you get cosine theta equals negative 1/2. So now that's what cosine is equal to. We want the value of theta, so we have to take the arc cosine on both sides. But before we do that, let's just review what it means for cosine to be negative 1/2. If we go back to the unit circle, we know that all students take class. So now regardless of the reference angle we get in return, this is saying that cosine is negative. So if cosine is negative, that means we can't be in quadrant 1 and we can't be in quadrant 2. We're looking for a second quadrant angle and a third quadrant angle because cosine is negative. So what we're going to do, we're going to take the inverse cosine and say that our angle is the inverse cosine of negative 1/2. So take the inverse cosine, and the calculator should spit out a value of 120 degrees. However, we're not done yet. That's our second quadrant angle, but if we go back, we said that we should be in the second quadrant. We have it. And we should be in the third quadrant. We don't have that yet. So let's sketch an angle of 120 degrees and try to calculate our reference angle. 120 degrees looks like that, in which our reference angle is our distance from the x-axis. The x-axis is 180 degrees. If we're at 120, we have 60 degrees remaining to get to our angle of rotation, so that's our reference angle. So now this equation says that cosine is negative, which is why we're in quadrant 2 and quadrant 3. So since we went 60 degrees up, we also want a solution which goes 60 degrees down. So 120 is not our only solution. We have another solution of 180 plus 60, which is 240. So they are our two solutions. 120 degrees and 240 degrees. Let's just summarize what we did here. We solved for cosine just like we would solve for x. We took the inverse cosine of what we got, and that supplied our reference angle. Our reference angle will be put into any quadrant which satisfies this being positive or negative. Whether it's sine, cosine, or tangent, depends on the problem that's given. Let's do another example. So now we're working with sine. The first thing we're going to do, we're going to solve for sine, and then we're going to see is sine positive or is sine negative. Then it will determine which two quadrants my solution will lie in. So let's assume this 5. 5 sine theta plus 15 is equal to sine theta plus 12. Let's subtract sine theta from both sides, giving us 4 sine theta plus 15 is equal to 12. And now we'll subtract 15 from both sides. 4 sine theta equals negative 3. Finally, we'll divide by 4. So sine theta equals negative 3 over 4. So now, regardless of the reference angle we get, this says sine is negative. That's telling me that I should be in quadrant 3 and quadrant 4 because sine is negative. So first I'm going to find my reference angle, and then I'm going to put that reference angle in the third quadrant and in the fourth quadrant. This is not a special right triangle value, so I'll need my calculator here. And make sure your calculators are in degree mode. We've been in radian mode for some time now. Just verify that your calculators are in degree mode when you're finding your reference angle. We are. So let's continue. We're taking the inverse sine, second sine, of negative 3 divided by 4. And again, this is our reference angle. So we have negative 48.6. is our reference angle. Negative 48.6. So now what we have to do is put that reference angle into the quadrants which we have already identified. We've identified the third and fourth quadrant where sine is negative. So what we're going to do, we're going to put 48.6 degrees down into the third quadrant, and we're going to put 48.6 down into the fourth quadrant. Okay, so what we're looking for is this angle of rotation and this angle of rotation. So this is 180, we're 48.6 after that, so we get a solution of 180 plus 48.6. That's just one of our solutions. Let's see, 228.6. We also get a solution of 360 minus 48.6. So what we're really doing, we're finding the coterminal angle. So you get, let's see, 12, 11.4, 3, 11.4. Okay, so again, you're finding your reference angle. You're putting the reference angle into the quadrants that satisfy sine being positive or negative. In this case, sine was negative, so our reference angle, 48.6, was going into the third quadrant and into the fourth quadrant. One last example. So now let's solve for all values of theta with a cosecant. Problem is, we don't have the cosecant button in our calculator to find a reference angle, but we do know that cosecant is the reciprocal of sine. So we're going to treat this as a sine equation. First, we'll solve for cosecant. So let's distribute the 3. 3 cosecant theta minus 3 is equal to cosecant theta plus 2. So let's subtract cosecant from both sides, giving us 2 cosecant, and let's add 3 to both sides, equals 5. So now divide by 2, cosecant is equal to 5 over 2. Well, if cosecant is 5 over 2, then sine is its reciprocal, 2 over 5. So now regardless of the reference angle I get, this says sine is positive. What we're looking for, a first quadrant angle and a second quadrant angle. So let's find the inverse sine of 2 over 5. And that's not a special right triangle value, so I need my calculator. Second sine, 2 divided by 5. And that will give me my reference angle of 23.6. Well, that's my first quadrant angle. Remember, I wanted first and second. 23.6 is my reference angle, so I want to go up 23.6 and up 23.6. Well, this is 180. We want to be 23.6 before that. 156.4. And all I did there was 180 minus 23.6 because this is 180 and we're 23.6 before that. So that's how you solve trigonometric equations.